All right, welcome back to the final day in our Artemis week. I am so glad to be coming to you live from the Kennedy Space Center, sort of. I'm Joshua Santora, bringing you two amazing ladies who are working to do what needs to be done once we get to the moon. Artemis is getting to the moon with our eyes on Mars, but it's only step one. And it's a big step, but I have with me today Jackie Quinn, the MSolo project manager. Jackie, thanks for being here.
Oh, it's great to be with you. Thanks.
Yeah, and then also joined by Janine Captain, both ladies applied chemists, I think. Is that correct?
I am an applied chemist, yes.
And I'm an engineer.
Very cool. Yes, amazing skills and talents. Chemistry, definitely not my forte. So I appreciate ladies like you who are conquering the difficult stuff in my mind. So let's jump right in. Can you give me both a snapshot of what you do? Obviously, we saw job titles, principal investigator and project manager. What do those things mean? Jackie, let's start with you.
Oh, okay. So I'm the project manager for MSolo, and I work alongside Janine. Basically, my functions are to deal with the overall management of the project, like schedule adherence, ensuring that we have enough budget. I also make sure we have the staff available with the right skill set to work on the project. And, you know, occasionally I get to put in a few tidbits based on my technical background. So that's what I do.
And I think that's a really important note of just the fact that there's a lot of things that are not technical that go into this world. So definitely a diverse skill set required. So I'm sure that's, again, not necessarily your favorite thing to do, but very important aspects to the job. Janine, as
True.
a principal investigator, that sounds really important. So for MSolo, what does that mean?
So as the principal investigator for MSolo, I'm responsible for the science and the instrument performance, but you know, I'm not the most important thing at all. We work with an amazing team of folks at KSC and different NASA centers and our commercial partners, and we're ready to get this instrument to go to the moon.
So we got to take a step back for a second because we didn't actually talk about what MSolo is. So we kind of know what you do for this mission or payload, or I'm not exactly sure the right way to describe it. We have very interesting terms for things like this. Can you tell us more about what is MSolo?
Yeah, sure. So MSolo stands for Mass Spectrometer Observing Lunar Operations. You know, NASA loves the acronyms. So this is a modified commercial instrument that measures gases. So we're partnering with Inficon, a company in Syracuse, New York. Here on Earth, this instrument is used in the semiconductor industry, but we're actually going to use it to detect water and other volatiles on the lunar surface.
And can you give me kind of a picture of what does that mean exactly? You use an interesting term there, a volatile. Obviously, it's a research mission. Can you tell me a little bit more about that?
Yeah, so in planetary science, when we talk about volatiles, we're talking about compounds that have low boiling points. So things that are typically found in the atmosphere. So things, oxygen, nitrogen, and water are all considered volatiles. And so we're looking at measuring things that we can use as resources on the lunar surface. And I think we have a video if you want to play the video now for MSolo.
Yeah, let's take a look.
MSolo stands for Mass Spectrometer Observing Lunar Operations. We took an off-the-shelf mass spectrometer and worked with Inficon to ruggedize the design to withstand the harshness of space. We bolstered the glass instrument detector, redesigned the avionics boards for better heat flow and increased radiation tolerance, and applied other standard spaceflight practices into the design. On the lunar surface, MSolo can measure resources like water, crucial to deep space exploration, and it can measure the gases coming off a lander during touchdown. This is important so we know what is truly coming from the moon and what we brought with us. Being able to identify the lander signature will ensure we are only measuring what was already on the lunar surface. MSolo will be sent to the moon as part of the Commercial Lunar Payload Services contract. Essentially, commercial companies are building lunar landers, and technology like ours is hitching a ride down to the surface. Not only will MSolo help us learn more about the moon and ultimately change the way we explore our solar system, but the new rugged design we helped create is changing things down here on Earth too. By modifying an off-the-shelf mass spectrometer, NASA helped Inficon identify ways they could improve their product that would also help universities and other researchers using their equipment in harsh environments here on Earth. In Costa Rica, investigators are flying a commercial mass spectrometer on drones over volcanoes, safely detecting what gases are being emitted. Information from volcanic plumes provides insight into what is happening inside the volcano, alerting researchers if a major eruption is imminent. We are proud of MSolo's capabilities in space and right here on Earth. And now we're headed to the moon. From Kennedy Space Center, I'm Patricia Valendia.
All right, so one of the many things in that video was I heard them mention I think it's the Commercial Lunar Payload Services, which I believe we affectionately call CLPS. What is CLPS? It sounds really important for our future on the moon.
Yeah, it is. So, as you mentioned, the Commercial Lunar Payload Services Program is NASA's way of partnering with the commercial lunar market using emerging lander technologies to deliver NASA's ready-to-fly payloads to the surface of the moon. So MSolo-1 is set to fly on the Astrobotic lander, and that was awarded during the first round of the CLPS opportunities. So that mission is going to be going to the equatorial region of the moon. And so while we don't expect to find water there, as was mentioned in the video, it's important for us to understand what we brought with us and really establish a baseline of what our environment is going to look like when we land with these commercial partners. And so from there, we're also going to look for some science opportunities in trying to understand how the thermal cycling influences the abundance of gases on the moon as well. And that mission is set to fly in 2021. So we're really excited to have an instrument on the lunar surface next year. And then a second MSolo instrument is actually going to fly on the recently awarded Maston lander. And that is actually going to land near the lunar South Pole. And that's going to land on the next year in 2022.
So I think you mentioned water ice as being something different about these two regions. Is that really the big difference there and why you go to the pole versus go to the equatorial region?
Yeah, that is one of the big differences. The water is such a resource that we really need to, it's the easiest resource for us to use. And so that's why we want to go to these polar areas where we think there is stable water ice.
Awesome. And can you give me kind of a snapshot of what are your backgrounds in? Obviously, we mentioned engineer and applied chemist, but how do you get to the point where you're working on a science instrument to go to the moon to use water ice? Like that's a really amazing NASA-y kind of thing to do.
Yeah, so actually when I got my graduate degree working in analytical chemistry, and I worked on building vacuum chambers and operating, doing vacuum science. And so I was able to take that experience and apply it to what we were doing here. So having that hands-on experience for me really allowed me to jump in and do some technology development and really focus on, going to the moon and, simulating that environment of the moon here on Earth.
Very cool. And we are wrapping up here about out of time. Jackie, I wanted to let you answer that question if you had more thoughts. And also just ask you as well, what's it like to be a part of the Artemis program? Obviously, this is a huge flagship moment for the agency as we're returning to the moon 50 years after the first time around. So just curious to hear from you what that's been like.
Well, it's really cool to be part of the Artemis program because, it's the next step that we're taking where we're going to send the first woman and the next man back to the moon. And I know you're talking to two PhD women engineer and scientists, and that's, especially meaningful for us. We do have another mission. The NASA Viper mission is also planned to be delivered to the surface of the moon by a CLPS provider. Viper, it stands for the Volatiles Investigating Polar Exploration Rover. And then just to give you a little preview, that Viper mission is like a golf-sized mobile robot that we're sending to the South Pole of the moon to get a close-up view of the location and the concentration of water ice. And that is where we plan to, the humans will land on the Artemis program in 2024. Viper is the first resource mapping mission on another celestial body, that resource being water. And water, you see, can be turned into oxygen, or you can turn the oxygen in from the water into breathing air and also into fuel. The Viper rover in particular carries a suite of scientific instruments that includes a neutron spectrometer, a near-infrared spectrometer, and also MSolo, in addition to a drill that'll take a meter-deep sample and carry the lunar soil to the surface for evaluation of its volatiles. And collectively, those instruments will determine the composition and the concentration of the resources at the South Pole, including water. So we believe that Viper robotic mission will bring us closer to NASA's ultimate goal of a sustainable long-term presence on the moon, and making it possible to explore even further onto Mars and beyond. So as you note, our first step, being part of that Artemis mission and really making it, being part of it is just super foundational. And I know we're all super excited. As far as the MSolo team, I give a shout out to the team. We have an amazing group of engineers and scientists that we work with, and Janine and I are truly privileged to be part of that MSolo team and also to be part of the Viper team. So appreciate it.
Yeah, Jackie, Janine, appreciate you joining us. Cannot wait to see you guys with science on the moon again very, very soon.
Absolutely.
Thank you.
All right, and for all of our viewers out there, that's going to do it for today. Want to give everybody a clue. We're taking a break from this program. We're getting ready for Demo 2 mission coming up in just a week and a half. Very exciting as humans take flight from America to the space station once again. But that's going to do it from all for us today. And reminding you, as always, that even the sky isn't the limit.